Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Slight Asymmetry by L.M. Damasi, and here are the rules. We have standard Sudoku rules applied, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region. We also have thick blue lines are region sum lines, and box borders divide region sum lines into segments with equal sums. So, for example, this line can be divided into a segment here, a segment here, a segment here, a segment here, and a segment here, and a segment here. So, for example, if this were, say, 2 and 6, this would have to be an 8. Because the sum of the segments must add up to the same sum. And those are examples of how region sum lines work. I'm actually wondering where the slight asymmetry here is. It looks very symmetrical around here. Oh, the slight asymmetry is right there. Okay. We have a dotted green lines are German whisper lines, or as I like to call them, whisper 5 lines, which was a term that a setter invented, which I thought made sense because it's very easily extendable. Where adjacent digits on a German whisper line have a difference of at least 5. So, for example, if this were, say, a 3, this would have to be 8 or 9, because digits that are 5 or more away from 3 are 8 and 9. And that's an example of how whisper 5 / German whisper lines work. And we have the thin pink line are Renban lines, where digits on a Renban line are a set of consecutive digits in any order, and there are no repeats possible on a Renban line. So you could have something like, say, 3, 2, 6, 7. That doesn't work. 3, 2, 4, 6, and 5. And this would form a valid Renban line because 2, 3, 4, 5, 6 are a set of consecutive digits. What you could not have is something like 2, 3, 5, 6, 7, because that's not consecutive, because 2 and 3 are consecutive with each other, but they're not consecutive with 5, 6, and 7. And that's an example of how Renban lines work, and those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, the first thing that comes to me is this digit is going to be the same sum as these 3 digits here. And there are unique digits in this, on this line. So therefore, this must be 1, 2, and 3 added up at least. So this has to be 6, 7, 8, or 9. Which is a high digit, right? Now, on a whisper 5 line, you're always going to alternate between low digits and high digits. Because what digits can be next to a low digits? The low digits being 1 through 4, the high digits being 6 through 9. 1 can be next to 6 through 9, 2 can be next to 7 through 9, 3 can be next to 8 or 9, and 4 can be next to only 9, which are all high digits. What digits can be next to a high digit on a whisper 5 line? 6 can be next to 1, 7 can be next to 1 or 2, 8 can be next to 1 through 3, and 9 can be next to 1 through 4, which are all low digits. So on a whisper 5 line, you'll always alternate between low digits and high digits. And notice I did not say anything about 5, because 5 can never be on a whisper 5 line. If you subtract 5 or more from 5, what do you get? You get 0 or less, which is not a normal Sudoku digit. What happens if you add 5 or more to 5? What do you get? You get 10 or more, which is not a digit. So 5 can never be on a whisper 5 line, and you'll always alternate between low digits and high digits on a whisper 5 line. So because this is a high digit, these have to be low. Because this is a low digit, these must be high. And again, we'll keep alternating. These must be low. These must be high. These must be low. These must be high. And this must be low here. So this digit is the same as that. It's going to be a high digit. And what digit can be next to 4 unique high digits? And the only possible one would be a 1. So this is 1, which means in the rest of this central box, the remaining digits cannot be high, and they can't be 1. So they have to be 2, 3, and 4 with 5. So this is 2, 3, 4, 5. And it has, since it's 2, 3, 4, 5, the remaining digit to form a renban must be either 1 or 6, but it cannot be 1 because of 1 in the row. So this has to be a 6, which is a high. And 6 can only add up with 1 and 2 to add up to a single digit of 9. So this must be a 1-2 pair here, which adds up to 9. So this is 9 here, which means this is 9 also. This is the sum of 3 digits adding up to 9. We're not sure which. These add up to 9, and they cannot have 1, 2, or 6. So that eliminates 1, 8, 2, 7, and 3, 6 as possibilities. So this is a 4, 5 pair here. Remaining digits. These digits must be the same as this one. So this is also going to be adding up to, is the sum of 3 digits, but both of these add up to the same digit here. So all of these must then, 5 unique digits must be able to add up to this digit times 2. Well, you can't have 9 here because of 9 in the central box, because these digits are the same. And we can't have 7 here, because if you double 7, that's only 14. And 5 digits must add up to at least 15, right? Which is 1, 2, 3, 4, 5. So therefore, it cannot be 7 or less. It cannot be 9. It has to be 8 here. So this is 8, which is going to be equal to 1, 2, 3, 4, and 6 adding up. Because 1, 2, 3, 4, 6 adds up to 16, which is 8 doubled. So this must be 1, 2, 3, 4, 6 also. This can't be 1 because of 1 in the column. This can't be 1 because of 1 in the column. Same here. To add up to 8 with these possible combinations, it has to be 1, 3, and 4. And this must be 2 and 6. And this can't be 6 because of 6 in the row. So this is 2. That's 6. Oops. Same thing here. This must be 1, 3, and 4 here. So no 2, 6 here. So this has to be a 2, 6 pair here. And this cannot be 6 because of 6 on the renban. You can't have repeats. So this is 2, which makes that 6. So 2 cannot be any of these. 1, 3, 4 as a triplet. Eliminate 1, 3, 4 in the rest of the row. This can't be 4. It's 5, which makes that 4. This renban has to have 2 and 6 in it. And then there's 4 more digits. So that includes 3, 4, and 5, definitely. And either 1 or 7. We're not sure which. This cannot have 1, 3, 4, or 5 because of 1, 3, 4, 5, 1, 3, 4 triplet, and the 5 in the row. So this has to be 7 then, which means the remaining digits on this renban are 3, 4, and 5. This can't be 4 because of 4 in the row, so 4 has to be here. This can't be 3 because of the 1, 3, 4 triplet in the column. So this must be 5 here, and this is 3. Okay. Remaining digits in row 7 then. These have to be 2, 6, and 9. And this cannot be 2 here, so this is 6 or 9, and then we have 2, 6, or 9 here. Remaining digits in row 5 have to be 7, 8, and 9. Because of the 3, 4, 5 triplet in the row. And because this is 3, 4, 5, 5 cannot be one of these digits here. So the 5 has to be one of these 2 digits here. This is 2, 3, 4 as a triplet, which eliminates 2, 3, 4 in the rest of the column. So this cannot be 1, it cannot be 2, 3, 4, or 6. To add up to 9 then, this must be 5 with 1 or 3. So we have to have 5 here. This is 1, 3 as a pair. To add up to 9 for these two digits, you don't have 1 of it, 3 or 5 available. That eliminates 1, 8, 3, 6, and 4, 5 as the pair, so this must be 2 and 7. 7 cannot be here because of 7 in the column, so this is 2, that's 7. I'll also eliminate 7 here. So, remaining digits in the central box are 6 and 7. Well, what digit can be next to 6 or 7 on a Whisper 5 line? 3 cannot be next to 6 or 7, so this must be 1, which makes this 3. 6 and 7 can be next to 1 or 2 here, that's fine. This cannot be 1 or 2 because of the 1-2 pair in the box, so this has to be 3 or 4 here. 3 or 4 cannot be next to 7 on a Whisper 5 line, and it's next to 2 unique digits on the Whisper 5 line, so this can't be 4, which makes that 3. 3 has to be next to 8 and 9 on a Whisper 5 line. This can't be 9 because of 9 in the row, so this is 8, that's 9, which makes this 8, which makes that 7. No 9 is possible here because of 9 in the column. 3 eliminates 3 as a possibility here and here. Remaining digits in this cannot be 8 or 9. It's a high digit, which is next to 2 unique digits on a Whisper 5 line. So it can't be 6, it must be 7, which makes this not 1 or 2 has to be next to 7 on a Whisper 5 line. This can't be 1 because of 1 in the box. So that's 2, this is 1. 2 and 1 are both next to this digit here on the Whisper 5 line, but it can't be 7, so this is 8 or 9. 3, this digit is also next to a 6 or 7 on the Whisper 5 line, so it can't be 3 or 4, it's 1, which means this can't be 1 here. This digit is next to 8 on a Whisper 5 line, so this cannot be 4, and this can't be 4, which makes that 3 and 4, which eliminates 4 in the rest of the column. So this can't be 4, that's 2, this can't be 2, that's 3. Therefore, this cannot be 3 here in the central box. This 4, 5 pair eliminates 4, 5 in the rest of the row, so this can't be 4, 5, it's 3, which makes this 1, which makes that 4. 2 eliminates 2 here, so it's 1 and 2. 2 cannot be next to 6 on a Whisper 5 line, so this is 7, and that's 6. We could also have done it this way too. And the rest, we basically have to do from normal Sudoku. Remaining digits in row 3 are 4 and 6. In row 4, we have 7, 8, and 5, but 8 cannot be either digit here because of the 8 in the box. So 8 has to be here, then this is 5, 7, and this can't be 7 because of 7 in the column. So that's 5, that's 7. Remaining digits in row 6. This must be a 9 because that's the only place for it in that box. And this has to be a 4, 5 pair here. Remaining digits in column 7. We have 3 and 8. This can't be 8 because of 8 in the box, so that's 3, which makes that 8. Remaining digits in column 2. We have 1, 3, 9. 3 cannot be here. 3 cannot be here, so 3 has to be here. Where are 1 and 9 available then? They have to be in these two spots. Remaining digits of column 3. We have 2, 6, and 9 available. This can't be 2 because of 2 in the box, so 2 has to be here. Therefore, that forces this to be a 6, 9 pair here, which eliminates 6 and 9 in the rest of the box. This can't be 9 anymore, so this is 1. This can't be 6 anymore, so it's 4, which makes that 6. 1 eliminates 1 here, so it's 9, which eliminates 9 here, so it's 6, which makes that 2, and makes that 9. Okay. Remaining digits in column 1. We have 1, 5, and 8. 1 can't be here, so 1 has to be here, and this becomes a 5, 8 pair. Let's see. The remaining digits in column 5 are 7, 8, and 9. And this can't be 9 because of 9 in the row. This is 7, 8, or 9. That's fine. Let's continue with the ones we have 5 digits on. Remaining digits in column 4 are 4, 5, 7, 9. And this cannot be 5 or 7 because of 5 in the box, 7 in the row. This can't be 4 here. So this is 5, 7, 9 here. Remaining digits of column 6, we have... Actually, let's do it this way. We have 8 ones left. Where's the remaining one in the grid? It has to be here. 2s. We have 8 2s. Where's the remaining 2 in the grid? It has to be there. 3. We have 8 3s. Where's the remaining 3? It must be there. This must be a 4, 5 pair here. I think it's all we can do. Yeah, we don't really have any other information. Let's just continue then. This is 4, 5 as a pair, which means we can eliminate 4 and 5 in the rest of the column. So what are the remaining digits? It's 6 and 7. 6 eliminates 6 here, so this is 7, which makes that 6. 7 eliminates 7 here. We now have a 4, 5, 9 triplet in column 4, which eliminates 4, 5, and 9 in the rest of the column. This can't be 4, 5, or 9. It's 7, which eliminates 7 here. We now have an 8, 9 pair in column 5, which eliminates 8 and 9 in the rest of the column and in the box it's in. So this is 4, this is 5, that's 9. This can't be 8, so this is 7. 5 eliminates 5 here, so that's 4. 4 eliminates 4 here, so it's 5, which makes that 4, which makes that 5, which makes that 4. 5 eliminates 5 here, so it's 8 and 5. 8 eliminates 8 here, so it's 9 and 8. 9 eliminates 9 here, so it's 6 and 9, which leaves that as a 6, this as a 5, and this as a... Wait, that doesn't work. This is an 8, and this is a 5. Yeah, I mean, fairly straightforward. The slight asymmetry was definitely needed to solve this puzzle. And that was essentially the break-in here. Yeah, just nice little puzzle with, some features, well, a lot of features you'll often find in these variant Sudoku puzzles. So, nice little introduction to all of them. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.